there's two other theorems that we have here that kind of come together. There's the irrational root theorem and then the complex root theorem, and what it says is if a plus root b is a root, then its conjugate will also be a root. And that works for any complex number, any irrational number in this form. So it has to have a square root there. It can't be, this can't be like a 9 or something. And then same idea over here, except I didn't write this correctly. This would be a minus bi is also a root. And so that tells us, so in this example it says if 1 minus root 5 is a root, 3i is a root, and negative 4 plus 6i is a root. They're all roots with rational coefficients. What other roots must the polynomial have? Well, since 1 minus root 5 is a root, one of the other ones will be 1 plus root 5. Since 3i is a root, its conjugate of negative 3i is a root. And since negative 4 plus 6i is a root, negative 4 minus 6i is a root. So just by knowing these three, we know 3 more, which means this actually will have a total, has to have a total of 6 roots. So this would be polynomial 6. Didn't ask that, but so if an irrational number in the form a plus root b or an imaginary number is a root, then their conjugates will also be roots. If a is a 0 of an equation, then x minus a is a factor, and the converse is also true. So we can actually write polynomial functions if we know some of the zeros. And so what we do here, if 3 is a 0, so this means x minus 3 is one of our factors. This one gets a little tricky. If 1 minus 3 root 6 is a 0, then x minus that number, so minus, and then I put this in parentheses because that negative will get distributed, then this is a factor. Now we have to put one more here because 1 minus 3 root 6 is a 0, which means 1 plus 3 root 6 has to be a 0 also. And so another factor here is x minus this number. And so we could write a polynomial. Let's just write p of x for our polynomial equals x minus 3 times, we'll distribute our negative here, x minus 1 plus 3 root 6. I said 1, but I put an x, and then x, distribute this negative, x minus 1 minus 3 root 6. We'd actually multiply the complex roots out first. X times x is x squared minus x minus 3 root 6x. So that was just, those three came from distributing x. Now we distribute the negative 1, so minus x plus 1 plus 3 root 6. And now distributing the 3 root 6, we have plus 3 root 6x minus 3 root 6, running out of room here, and then minus, but just put it down here, 3 root 6 times 3 root 6 is 3 times 3 is 9, times 6 is 54. I'm not going to multiply in this x minus 3 yet. So as you see, the concept of making the polynomial isn't too bad. It's just a matter of multiplying things out, makes it a little longer. So let's see, we have an x squared. We have a negative x, another negative x. So we have minus 2x. We have negative 3 root 6x and a positive 3 root 6x, which is 0. We already used this negative x. We have 3 root 6 and a negative 3 root 6. Those become 0 and 1, and negative 54 is negative 53. Well, that worked out nice. Doesn't have any irrational numbers in it. Now we can multiply this out. We get x cubed minus 2x squared minus 53x, and then distributing the negative 3 minus 3x squared plus 6x minus 159, plus 159. And then adding like terms, x cubed minus 5x squared minus 47x plus 159 is our polynomial function of least degree that has these number as the roots. Now when it says least degree, we went as low as possible. There were 3 zeros here. We could have added on another one. We could have put like x plus 7 or an x, and these things still would have been zeros. We just would have had extra, which would, having these would be x to the 5th, and so it said of least degree, so that means they don't want any extra zeros in there. And so there is our answer, and that is lesson 6.7, dealing with polynomial equations.